Good day, everyone. I know that you guys already learned and have knowledge about the union of a set, intersection of a set, and the difference of a set. So, for today's discussion, we will talk about the symmetric difference of a set. But first, let us define what is a symmetric difference all about. An element is in the symmetric difference if it appears in only one of the sets, meaning the intersection of the set is excluded. Symmetric difference is also called as the disjunctive union, since symmetric difference means the elements present in A or B or set A or B but not in A and B. So take note that symmetric difference between any two sets is defined as a new set containing all the elements present in either of the sets but not in their intersection. Meaning, the union of the two sets minus the intersection of the set is the symmetric difference of a set. Let me explain to you how a symmetric difference of a set works. In this given example, we will find the symmetric difference based on the given sets provided below, which are the set J and L. Set J contains the elements 4, 8, 10, and 12, while set L has the elements of 1, 4, 7, and 10. In finding the symmetric difference of these sets, we should first identify the intersection of the set, which are the elements 4 and 10. Based on the definition that we learned about the symmetric difference, we should exclude the intersection of the set. That is why the remaining elements are the symmetric difference, and those are 8, 12, and 17. So the next subtopic of the symmetric difference is the notation of it. So the first notation states that the symmetric difference of A with respect to B is equals to the union of A and B minus the intersection of A and B. It implies that A delta B represents a set that contains the elements from the union of two sets, which are A and B, minus the intersection between them. In these notations, the three different set operations are involved, which are the union, intersection, and the difference of two sets. For example, given the two sets below, which are set M and set K, find the symmetric difference of M with respect to K. Set M has an element of 5, 10, 15, and 20, while set K contains the elements of 15, 20, 25, and 30. So by using the notation I've discussed earlier, we can come up with a solution like this one. M delta K is equals to the union of M and K minus the intersection of M and K. First, let us identify the union of M and K. So, the union of these two sets are 5, 10, 15, 20, 25, and 30. Next is the intersection of the given sets, which are 15 and 20. So, by subtracting the two, which are the intersection and the union of the given sets, the symmetric difference of M with respect to K are 5, 10, 25, and 30. We can also use the Venn diagram representation in order for us to easily solve the given sets by using the notation in which we can come up with the same or equal results, since Venn diagram are the most appropriate tool to understand the data or sets visually. So the next notation of a symmetric difference is shown in your screen. It is read as the symmetric difference of A with respect to B is equals to A minus B union B minus A. Meaning, it is is an equivalent expression for the symmetric differences, since it is stated in this presentation that the union of all the elements present in A but not in B with all the B's elements but not also in A. So the equation above is said to be symmetric since we can change the set A and B positions with no effect on its results. For us to clearly understand this symmetric difference notation, let us study the given example. We will use the same example or given example to prove that the results are equal or yes, still equal despite of the difference notation used. The given example states that given the two sets below, which are M and K, find the symmetric difference of M with respect to K using the notation A delta B is equals to A minus B union B minus A. So set M is composed of the elements 5, 10, 15, 20, while set K contains the elements 15, 20, 25, and 30. By using the notation discussed earlier, we should find first the difference of the elements M and K, which is M minus K. M minus K is equals to the elements 5 and 10, while on the other hand, K minus M is equals to the elements of 25 and 30. The symmetric difference of M with respect to K are the elements 5, 10, 25, and 30. Since we will combine the results of the difference of the given two sets, which are M minus K and K minus M, so this is the Venn diagram representation of the given example. It is shown in the screen of the video presentation.
Difference between sets versus symmetric difference. Symmetric difference undergoes some difference operation as well. The name symmetric suggests that the operation must be symmetric. However, we know for a fact that the difference between sets is not symmetric. The symmetric nature of symmetric differences sets them apart from the difference between sets. There are some properties of symmetric difference, one of which is the commutativity property. The symmetric difference of A with respect to B is equal to the symmetric difference of B with respect to A. It is represented as A symmetric differences of B is equals to B symmetric differences of A, depending on the given set. In the application of mathematics, any operation is said to be commutative if you can rearrange the operands without changing the outcome. Here are some examples that prove that symmetric difference is commutative using the following sets. X is equals to the set of elements 10, 20, 30, and 40. Y is equals to the set of elements 30, 35, 40, and 45. Here are some steps that we need to follow in finding the solution. Step 1. Divide the equation into the left and right-handed sides. X delta y is equals to y delta of x. Step 2. Solve for the left-hand side. We know that x delta y is equals to the union of x and y minus the intersection of x and y. X union of y is the set of the elements 10, 20, 30, 35, 40, and 45. Y x intersecting y is the set of elements 30 and 40. The symmetric difference of x with respect to y is the set of elements 10, 20, 35, and 45. And in step 3, we need to solve for the right-hand side. The symmetric difference of y with respect to x is equals to y, the union of y and x, minus the intersection of y and x. The union of y and x is equals to the set of elements 10, 20, 30, 35, 40, and 45. While the intersection of y and x is equals to 30 and 40. The symmetric differences of y with respect to x is equals to y, the union of x minus y, the intersection of x is equals to the set of elements 10, 20, 35, and 45. The commutative property holds since the right and left hand sides are equal. Here are the second properties of symmetric difference. Number 2 is associativity property. The groupings of sets per symmetric differences will not affect the result. It's changing the parenthesis position in any expression of sets involving symmetric difference operation will not affect the results in any manner. Associative property of symmetric difference can be mathematically written as the symmetric differences of A with respect to B, delta C is equals to A, delta B, the symmetric differences of C. This is the example that proved that symmetric difference is associative using the following sets. L is equals to the collection of sets 10, 11, 12, and 13, while M is equals to the collection of sets 13, 2, 4, and 12. N is equals to the collection of sets 12, 8, 9, and 13. Here are some steps that we need to follow in finding the solution. Step 1. Divide the equation into the left and right hand sides. The symmetric differences of L with respect to M, delta N is equals to L, delta M, the symmetric differences of N. Step 2. Solve for the left hand side. We know that the symmetric differences of L with respect to M is equals to L, the union of M minus L, the intersection of N. L, the union of L and M is equals to the set of collection of elements 2, 4, 10, 11, 12, and 13. L intersecting M is equals to 12 and 13. The symmetric differences of L and M is equals to 2, 4, 10, and 11. The symmetric differences of L and with respect to M, delta N is equals to the collection of sets of elements 2, 4, 8, 9, 10, 11, 12, and 13. In step 3, solve for the right hand side. The symmetric differences of N, M with respect to N is equals to X, the union of N minus M and intersecting N. M, the union of N is equals to the collection of set of elements 2, 4, 8, 9, 12, and 13. M intersecting N is equals to 12 and 13, while the symmetric differences of N with respect to N is equals to 2, 4, 8, and 9. L delta M symmetric differences of N is equals to 2, 4, 8, 9, 10, 11, 12, and 13. The associative property holds since the right and left hand sides are equal.
Idempotent property. So, idempotent property is the element of a set is unchanged in value when operated by itself. So, the symmetric difference of a set with itself will give the null set. In mathematically, it can be written as A symmetric difference A equals. So, for example, prove that symmetric difference is idempotent using the given set below. Z equals set of 3, 6, 9, 12. So the solution is say symmetric difference equals open parenthesis z union of z close parenthesis minus open parenthesis z intersection of z close parenthesis. Z union of z equals set of 3, 6, 9, 12. Z intersection of z equals set of 3, 6, 9, 12. Z symmetric difference of z equals open parenthesis z union of z close parenthesis minus open parenthesis z intersection of z close parenthesis. Z symmetric difference of z equals empty set R. So the symmetric difference of set Z with respect to itself is a null set, meaning it satisfies the idempotent property. So null sets property. Null sets property is it is any set symmetric difference with the null set will result in the set itself. It is represented as asymmetric difference equals A. For example, prove that symmetric difference is a null set property with the given set below. D equals set of 5, 10, 15, 20. So the solution is D symmetric of D equals open parenthesis union of D close parenthesis minus open parenthesis intersection of D close parenthesis. Union of D equals set of 5, 10, 15, 20. Intersection of D equals empty set. So, symmetric difference of D equals open parenthesis union of D close parenthesis minus open parenthesis intersection of D close parenthesis. Symmetric difference of D equals set of 5, 10, 15, 20. So the symmetric difference of D with respect to a null set is equal to itself.
So let us try to answer the given practice task. I will read first the given task, then pause the video for a second or a minute for you to answer the given task. So practice task 1. Giving the following sets below, find its symmetric difference using the notation A delta B, or the symmetric difference of A with respect to B is equals to the union of set A and B minus the intersection of A and B. Set K contains the elements 5, 4, 3, 2, and 1, while set L contains the elements of 10, 8, 6, 4, and 2. So, a Venn diagram representation is also shown in your screen. And now, pause the video for a second and answer the given task. Okay, so for its answer or solution, K delta L is equal to the union of K and L minus the intersection of K and L. K union L is equals to 1, 2, 3, 4, 5, 6, 8, and 10, while the intersection of K and L are 2 and 4. So, if we subtract the union and the intersection of set K and L, the result of the elements of the symmetric difference of K with respect to L are 1, 3, 5, 6, 8, and 10. Next is the practice task 2. Prove that the given sets below are associative using the associativity property of a symmetric difference. Shown in your screen are the sets and elements of P, Q, and R together with its Venn diagram representation. Pause for a second and answer the given problem. So, for us to come up with the answer to the given problem, first we should divide the equation into the left and right hand sides. So shown in your screen is on how we divided the equation. So the next step, or which is the step 2, solve for the left hand side, and we know that P delta Q is equals to P union Q minus P intersection Q. P union Q is equals to 3, 5, 6, 7, 8, 9, 12, and 15, while P intersection Q is equals to 6 and 9. So if we subtract these two results, the symmetric difference of P with respect to Q is equals to 3, 5, 7, 8, 12, and 15. Then we will now multiply the result with the elements of set R. So open parenthesis P delta Q, closing parenthesis delta R. R equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, and 15. So step 3. Solve for the right hand side. Q delta R is equals to Q union R minus Q intersection R. Q union R is equals to 1, 2, 3, 4, 6, 9, 12, and 15, while Q intersection R is equals to 6 and 9. So, if we subtract these two results again, the symmetric difference of Q with respect to R are equals to 1, 2, 3, 4, 12, and 15. Then we will now multiply set P to the results that we come up or we get. So P delta open parenthesis Q delta R closing parenthesis are equal to the elements of 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, and 15. The associative property holds since the right and left hand sides are equal. So that's it. I hope that you guys learned all the topic that we discussed in this video presentation. For your assignment, kindly answer the following.
Complement of a set. The complement of a set is the set that includes all the elements of the universal set that are not present in the given set. Let's say A is a set of all coins, which is a subset of a universal set that contains all coins and notes. So the complement of set A is a set of notes which do not include coins. In this article, we will discuss in detail the complement of a set, its definition along with properties, solve examples, and practice questions.
If universal set is having a subset A, then the complement of set A, which is represented as A prime, is other than the elements of set A, which includes the elements of the universal set but not the elements of set A. Here, A prime is equals to X is the element of U, such that X is not the element of A. In other words, the complement of a set A is the difference between the universal set and set A.
Example of complement of a set. If the universal set is all prime numbers up to 25 and set A has a set of elements 2, 3, and the complement of set A is other than the elements of A. For step 1, check for the universal set and the set for which you need to find the complements. Universal set or U are the sets of elements 2, 3, 5, 7, 11, 13, 17, 19, and 23. In A are set of elements 2, 3, and 5. In step 2, subtract the universal set and A. The sets of elements of U are 2, 3, 5, 7, 11, 13, 17, 19, and 23 subtracted to A sets of elements 2, 3, and 5. So the answer 7, 11, 13, 17, 19, and 23.
If A is a subset of the universal set, then A prime is also a subset of the universal set. Therefore, the union of A and A prime is the universal set. The intersection of set A and A prime provides the empty set. For example, if U is equals to 1, 2, 3, 4, 5, and A is equals to 4, 5, and B is equals to 1, 2, A prime is equals to 1, 2, 3, and B prime is equals to 3, 4, 5, then the union of A and A prime equals U equals 1, 2, 3, 4, 5. Also, the intersection of set A and A prime is equals to empty set.
Law of double complementation. In this law, the complement of the complemented set is the original set of the complement of A is equal to A. The complement of the set of complement of A, where the complement of A itself is the complement of A. The double complement of A is thus A itself. In earlier example, U or universal set has the set of elements 1, 2, 3, 4, and 5. And A are sets of elements 4 and 5. Then the complement A has a set of elements 1, 2, 3. The complement of complement A is equal to the complement of A which has the set of elements 4 and 5, which is equal to set A.
Law of empty set and universal set. The complement of the universal set is an empty set or null set, and the complement of the empty set is the universal set. Since the universal set contains all elements and the empty set contains no elements, therefore their complement is just opposite to each other, represented as null set equals U and universal set is equals to null set. In the above given example, set U or universal set is equals to 1, 2, 3, 4, 5, which contains all elements of set A and set B. As universal set contains all elements, therefore, universal set is equals to empty set and empty set is equals to 1, 2, 3, 4, and 5.
Here are the De Morgan's laws that talk about the complement. The complement of the union of two sets is equal to the complement of sets and their intersection. The union of A and B prime is equals to the intersection of A prime and B prime. The complement of the intersection of two sets is equal to the complement of sets and their union. The intersection of A and B prime is equals to the union of A prime and B prime. Here are the example of De Morgan's law. U is equals to 1, 2, 3, 4, 5, and A is equals to 4, 5, and B is equals to 1, 2. Thus, De Morgan's law of union, the union of A and B is equals to 1, 2, 4, 5, and the union of A and B prime is equals to 3, and thus, the intersection of A prime and B prime is equals to 3, as A prime is equals to 1, 2, 3, and B prime is equals to 3, 4, 5, so, the union of A and B prime is equals to the intersection of A prime and B prime is equals to 3. De Morgan's law of intersection. The intersection of A and B is equals to empty. The intersection of A and B prime is equals to 1, 2, 3, 4, 5, and thus the union of A prime and B prime is equals to 1, 2, 3, 4, 5, as A prime is equals to 1, 2, 3, and B prime is equals to 3, 4, 5. So, the intersection of A and B prime is equals to the union of A prime and B prime.
Important notes and complement of a set. The complement of the universal set is the empty set or null set. The intersection set contains the element that both sets have in common. The union of two sets is a set that contains all elements that are in A or B or in both.
Complement of a set example. Example number 1. If B is equals to set P and P is a multiple of 3, P and N, find B. P and N in the bracket indicates N is the universal set, where N is the set of natural number. So here's the solution. It is given that N equals U is equals to the set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. B is equals to set of P and P is a multiple of 3. P and then B is equals to the set of 3, 6, 9, 12, 15, etc. Therefore, the complement of the set B is equals to universal set minus B is equals to the set of 1, 2, 4, 5, 7, 8, 10, 11. So the answer is the set of 1, 2, 4, 5, 7, 8, 10, 11.
Example 2. If U is the universal set containing 50 students of class X of a coeducational school, and A be the set of all girls and it contains 25 girls, find the number of elements of the complement of a set of girls. Solution. If set A contains all girls, then the complement of set A is set of all boys. The difference between the universal set and set of all girls is the complement of a set of girls. Thus, the number of A prime is equals to 50 minus 25 is equals to 25. Therefore, the complement of the set contains 25 girls.
Find the complement of set A and set B, and also show the complement of A union B is equal to the intersection of A and B, where U are the elements 11, 12, 13, 14, 15, and 16. A are the set of elements 12 and 13, and B are the set of elements 13, 14, and 15. For our solution, complement of set A or complement A contains elements other than elements of set A. Therefore, the complement of A are the sets of elements 11, 14, 15, and 16. So the complement of A union B is equal to the intersection of A and B where the set of elements are 11 and 16. The answer are similarly to the complement B, has the set of element 11, 12, and 16. Now we will find the complement of A and B intersects, which includes the element that are contained the complement A as well as B. So the complement A and B intersect has a set of elements 11 and 16. Now, a union now A union B are the set of elements 12, 13, 14, and 15. So the complement of A union B or the complement of A union B are the set of elements 11 and 16.
Next is disjoint set. So, what is disjoint set? Disjoint set are sets that do not contain any common elements, and their intersection always result in an empty or a null set. For example, considering two distinct sets, set A contains or equal AB and set B is equal CD. It is quite obvious from observing this set that they have no common elements between them. The intersection of these two sets will be A intersection B is equal null set. Hence, we can conclude that the intersection of this joint set will always result in a null set. But we have to remember that not all null set intersection is a disjoint set. It can be changed. Now, how to find if two sets are disjoint set? To determine whether two sets are disjoint set, all we have to do is perform the intersection operation. Example, Consider the following group of set. Set A contains element 1, 2. Set B contain element 2, 3. And set C contain element 5, 3. Now, determine which of these set are disjoint set. We have to find out the disjoint set. Let's first consider the intersection of this set. A intersection B intersection C is equal null set. Now, let's apply the intersection operation on each pair of set. The first pair of set is set A intersection B. It contains 1, 2, intersection 2, 3. So, the intersection of this pair of set is A intersection B is equal to. The next pair of set is B intersection C is equal to 3 intersection 5, 3. And the intersection of this pair of set is B intersection C is equal to 3. A intersection C is equal 1, 2 intersection 5, 3. The intersection of this pair of set is A intersection C is equal to null set. So, we can see in this group of set, only set A and C are the disjoint set because they have intersection or a null intersection.
Next is we have the representation of disjoint sets through a Venn diagram. A Venn diagram is the most accurate and comprehensive tool used to depict a relationship between two or more sets. We can portray all of the essential set operations by using a Venn diagram. We can use Venn diagrams to indicate disjoint sets, and Ms. Cinco already mentioned about the disjoint sets that do not have any common element and have a null intersection. Adhering to this statement, the Venn diagram of disjoint sets has no overlapping region between the two sets. And to understand the Venn diagram depiction of disjoint sets, we could consider the two sets, which are the set A and B. Let set A has the elements of 2, 4, 6, and 8, and let set B has the elements of 3, 9, 10, and 12. The Venn diagram of these two sets is shown below, which set A has the elements of 2, 4, 6, and 8, and set B has the elements of 3, 9, 10, and 12. And since the two sets, which are the set A and B, do not have any intersecting elements, these are disjoint sets, and their Venn diagram will not have any overlapping region. Okay, let's solve another example to understand this concept further. We have here, consider the two sets, which are the set A and B. Set A has the elements of 10, 20, and 30, and set B has the elements of A, B, and C, and show the relationship through a Venn diagram. Solution: it is evident by analyzing the two sets that they do not have any intersecting elements. Hence, A intersecting B is equals to null or empty set. So sets A and B are disjoint sets. And the Venn diagram representation of these sets is shown below, which set A has the elements of 10, 20, and 30, and set B has the elements of A, B, and C. And since the two sets, which are the set A and B, don't have any intersecting elements, these are disjoint sets, and their Venn diagram will not have any overlapping region. Okay, next we have here the pairwise disjoint sets. We can understand pairwise disjoint sets as the pair of sets whose intersection results in a null set. This indicates that such set do not include any common element between them, and therefore, pairwise disjoint types of sets are considered the same as disjoint sets. Okay, we have here an example. Consider the following two sets. Set A and B. Set A has the elements of 5, 7, and 9, and set B has the elements of 1, 2, and 3. Determining and performing the intersection operation on sets A and B, set A has the elements of 5, 7, and 9, which, intersecting the elements of set B, which has the elements of 1, 2, and 3, would be equal to A intersecting B is equal to null or empty sets. Therefore, the two sets, which are the sets A and B, are pairwise disjoint sets. The last example for pairwise disjoint set is set P has the elements of 1 and 2, 3, and 4, 5, 6, which is a pairwise disjoint set. On the other hand, set P has the elements of 1, 2, and 2, 3, which is not a pairwise disjoint set, since we have 2 as the common element in two sets.
Union of disjoint sets. The disjoint union is a binary operation performed on two disjoint sets. So when we say binary operation, it is an operation on a rule that combines two real numbers or elements to produce another real numbers or elements in sets. So the disjoint union of two sets is just the union, but with the additional information that the two sets also don't have any elements in common. That is, we can use the phrase disjoint union to indicate that we've taken the union of two sets which have an empty intersection. So kapag sinabing disjoint union, we combine the two sets with no same elements. So the symbol for disjoint union is like a U shape with a sharp edge na makikita po natin sa ating PowerPoint. So the disjoint union can mean one of two things. The first definition is that the simple union, together with the assertion that the two sets don't overlap. For example, A have an element of 6 and 7, and B have an element of 8 and 9. So makikita natin na walang same element. These two sets don't overlap. No element of A is in B, and no element of B is in A. So that's why the union of A and B is equals to 6, 7, 8, and 9. So these are the disjoint union. These are the elements of disjoint union of A and B. So dito po sa first definition, we directly combine the elements in two sets to get the union of disjoint of set A and B. For the second definition, the operation do something to the elements of each set to make sure they don't overlap and then take the union. For example, set A have an element of 6 and 7 and B have an element of 6 and 8. So makikita natin na nag-overlap yung dalawang sets wherein may same element na number 6. So we want to message these two sets so that they become disjoint but are somehow still recognizably A and B. So kailangan nating mag-biject sa dalawang sets. So for example, ang set A is bijected with 0 and then B is bijected with 1. So when we say biject, the element is paired with exactly one element of the first set. So it can be paired with any number or elements. So dyan makikita natin na yung set A ay pinagbiject sa 0 and then ang set P ay bijected naman sa number 1. So therefore, set A is tuple with second element equal to 0 while everything in B is a tuple with second element equal to 1. So the disjoint of A is equal to 6 and 0 and 7 and 0. Then the disjoint of B is equal to 6 and 1, 8 and 1. So kapag pinag-combine natin yung dalawang sets, it is equal to 6 and 0, 7 and 0, 6 and 1, and 8 and 1. So this number are the disjoint union of set A and B. So dito sa second definition, we biject set A with 0 and B with 1 since they have the same element that is number 6. Then we get the union or the disjoint union of two sets. So that's the difference between the two definition or the two ways to get the disjoint union of an element.